Hello, grade 11 Sat. Today we want to continue our lesson or our chapter Dynamics, chapter 5, Dynamics. We started the previous time with types of forces. We said there are so many types of forces, and we will start to study one by one. In the previous video, we talked about two forces. The first one is the applied force. We said it is a force when you push an object direct or you pull an object direct. The second type of forces is what? Force of gravity. And we said we have it on Earth, and it is the force of gravity from Earth on all objects, okay? And this force has a formula. What is the formula for this force? F, the symbol of it, F, capital letter, small letter G, equals M times G. Mass times gravitational field strength or free fall acceleration, that equals 9.81. Okay, let's continue with other types of forces. We have normal force. Normal force, the symbol for it, capital letter N or Fn. Okay, is present whenever an object pushes on a surface. What does it mean? Any object. Now this laptop, while it is on the table, okay, this laptop is on the table, there is a normal force from the table on the laptop, and this normal force, it's opposite to what? Always it's opposite to the force of gravity. Look here, this arrow is the force of gravity or the weight of the object, and this arrow is the normal force, is perpendicular to the surfaces in contact. The second thing for normal force, that always normal force perpendicular to the surface. Okay, so if there is an object is not in contact with any surface, this object doesn't have a normal force. So for normal force, there must be an object on a surface, they are in contact, and always normal force perpendicular to the surface. Okay, look at these examples to see how it's perpendicular. When we have a flat surface, horizontal surface, the normal force here is it, vertical line perpendicular to the surface. Look here, I have an inclined plane surface. Okay, in this case, what do you see? That the normal force is not a straight line vertical. No, it is perpendicular to the surface. It forms a 90-degree angle with the surface. Okay, good. Normal force always acts perpendicular, as we said. Normal force is a response force to an applied force. There is no specific formula to solve for normal force, so we don't have a formula for normal force. Later on, when we start solving questions, you will see how we can find the normal force. Okay, good. Let's continue. The fourth type of forces here is the force of friction. For sure, all of you know the force of friction. Force of friction is present when two conditions are met. What are these two conditions? Number one, an object must be pressed against a rough surface. Rough surface. Either a force or a component of force must be acting parallel to the surface. Look here to understand. So two conditions, we need them for friction. Number one, that the object is in contact with the surface. The object is in contact with the surface or a rough surface. This is number one. The second one, look at the force. It is what? Parallel to the surface. Okay, so the applied force is parallel to the surface. In this case, Yes, there is friction. Okay, good. The symbol for force of friction, F, capital letter F small, or small letter f alone. Okay, now friction is described by the following equation. So now, till now, we have two equations for forces. The first one is the force of gravity. If I want to find it, I multiply the mass times 9.81. And the second formula now for the force of friction, and it equals mu times n. You remember what is n? N is the normal force, don't forget. So force of friction equals to mu times normal force. Okay, good. What is mu now? This symbol is a mu for you. Mu is the coefficient of friction. The coefficient of friction, what does it mean? Indicates surface roughness. The roughness of the surface. Now for sure not all surfaces have the same roughness. Some of them they are rough, some of them are smooth, and so on. So mu, it depends on the surface or type of surface we are using, or what the type of surface the object is on. The second thing, normal force, indicates how hard the surfaces are pressed together. We said normal force, what is it? Where do we have it? When do we have it? When two objects are in contact. Okay, when you put an object on another object, here we have a normal force. So for sure, friction depends on normal force, and also it depends on the roughness of the surface. Okay, and if I ask you what is the unit of normal force, what you will say? Newton, because and friction, Newton. So mu here, it has no unit, just a number. I give you a number. This is the roughness for this surface. Clear? I hope that it is clear. Now, problems involving friction usually mention a rough surface. You see in any question, a rough surface, or they can say direct friction. In any of these cases, you understand that there is a friction, because sometimes they don't mention any of these words. Okay, so it means no friction. Sometimes they say a smooth surface. So please be aware and focus while you are reading the question. Friction is equal to any force attempting to move the object forward but act in the opposite direction of any forward force. This is a very important note. Focus please to understand. Force of friction, for example, there's an object at rest and I start to push this object. Now the force of friction, it equals the force that I'm applying on this object. Okay? When the object starts to move, also this force equals the force of friction. So always force of friction equals what? Forward force. Okay? Always. Later on, when you start solving, you will see how we are going to apply this note when you start solving problems. Now, you have to understand and to know that we have two types for friction. One of them is static friction and the other kinetic friction. From their names, static, it means rest, no motion. Kinetic means motion. So static friction occurs when the pushing force is not strong enough to overcome the friction force. As a result, the object remains static at rest. So there is an object, you are pushing this object and the object is not moving. You are pushing. Why? Because this object now has static friction. You are pushing, you are applying a force, but the object doesn't move. Okay, and at any moment you know that the forward force that you are applying equals the static friction in the opposite direction to the applied force. Kinetic is the friction of moving objects. Now moving objects, while they are moving, still they have friction, but in this case we say that this is a kinetic friction, not static. Okay, so in both cases, we moving or at rest, there is a friction, but not the same friction. Okay, static friction is stronger than kinetic friction. This is a very important note also. And for sure, object at rest, you need a very high force, a very large force to make it start to move. Once the object starts to move, it's easier and to push that object, or to continue pushing this object. Okay, the last force we're going to talk about it today is tension. Tension, we use FT or capital letter T for tension. Most of the time we use capital letter T as a symbol for tension. Tension is what? Is a force exerted by ropes, strings, or wires. So when you have an object is attached to a rope or a string or a wire, what has to come to your mind? Tension. There is no specific formula for tension. Okay, so we don't have a formula for tension the same as force of gravity and force of friction. Tension has the same magnitude in every part of a particular rope of string. And in this case, for example, pulley, I have two objects here and I have one rope. At any point here or here, the tension is the same. So here, if you have the magnitude of tension here, you have to know direct that the tension here also is the same as this one. Okay, this is the meaning of this